Hello everyone, welcome to the live class. So guys, today we are having another very important session of atomic and molecular physics in which we will discuss some of the important points and a topic from which there are great chances that you can expect the questions in your upcoming CSIR Net Physics exam. Clear? So guys, this is a topic which is Breit's scheme. Please let me know in the comments once. Is everything all right? I think everything is okay now. Done. Even guys, you can just comment about it once that your side is everything fine, like the voice, the slide, and everything is okay. Done. Guys, if there will be any difficulty or any issue, you can let me know. You can comment about that. Clear? So let's just start the discussion. So as I've told you, like today's topic is very important, and sometimes if you need to find the spectroscopic term notations, like which is again a very important topic of atomic and molecular physics, as we have also done some discussion about it in our previous class of atomic and molecular physics. Okay, so today now I'm going to explain that Breit's scheme. Now when we use this scheme and how it is going to work, what are the steps we need to take to solve the questions by using the Breit's scheme. Okay, so guys, basically in this case, if we are having, in any of the cases, if we are having the equivalent electrons, okay, present in the configuration, if we are getting the equivalent electron case, to get the answer for two equivalent electrons, if we want to get the spectroscopic term notations, we can use the Breit's scheme there. Now exactly how this scheme work, what are the steps in the procedure of solving the questions or finding the spectroscopic term notations by using this method, we'll talk about each and everything. But before starting the discussion, I would like to make one thing clear. There are two situations. One is when there are equivalent electrons. This is the one case. Okay. So when there is equivalent electron situation, and another is non-equivalent. Clear? What we mean by equivalent and what we mean by non-equivalent cases, because this scheme will only work for the equivalent electron case. Now guys, let's say if the principal quantum number is same for the configuration we are having. Okay, so in that case we'll say that these are equivalent electrons, like Np2, like Nd4, like Ns2. Okay, like generally this is the completely filled shell. So for that there is a rule that corresponding to this one we will have the spectroscopic term notation, that is 1 is 0. So I don't need to write the 1 is 2 here. Directly we can find the answer corresponding to that. So these are the equivalent electrons, Np2 separately, Nd4 separately, because the principal quantum number is same for both the electrons which are present in the p orbital. This principal quantum number n is same for all the electrons which are present in the d orbital. So now I can say that this is the case of equivalent electrons, and for this case we use the Breit's scheme. Similarly, if I am going to talk about the non-equivalent electrons cases, which are like SS, SP, PD, okay, or some other situations. Why I am calling them non-equivalent? Because it is not necessary that every time you will have the principal quantum number corresponding to first S and second S same. So since they are present in the different states, okay, corresponding to different principal quantum numbers, that's why these are going to be the non-equivalent electrons. Is this clear till this point to everyone? Saddam, that is principal quantum number. Like we write now, 1s2, 2s, okay, and like that. So these are the values of n. Because here both the electrons are present corresponding to same value of n. So this is the case of equivalent electron. Is this clear till this point to everyone, guys? So this was the difference between equivalent and non-equivalent cases. So the scheme which we will study now, that is the Breit scheme, we will study this, or we'll talk about it corresponding to equivalent electrons. Is this clear? If it is clear, just let me know about it in the comments once. Clear, clear, clear? Quickly let me know in the comments. Yes, Harinder. Harinder, till now I have explained that what kind of electrons will be known as the equivalent or what kind of electrons will be known as the non-equivalent electrons. So equivalent electrons are those electrons for which the value of n, that means principal quantum number, is same. If I am talking about np2, how many electrons are present here? 2 electrons. So these 2 electrons are equivalent. Why? Because the value of n is same for both. If I am talking about nd4, so these 4 electrons are equivalent electrons because n value is same for all the 4 electrons. If I am talking about SS, for SS I don't know about the n values. They can be same for both the S, they can be different for both the S. So if they are different, and generally such kind of situation we consider that they are different, okay, then this is the case of non-equivalent electron. Is this clear to everyone till this point? Right, Mohammed Babar? Done. Is this okay now? So equivalent and non-equivalent clear. Now next point. See guys, in the Breit scheme, we'll take one example right now, that is of P2. Clear? It can be like 3P2 or 4P2 or something. But mainly when we write the spectroscopic term notation, what matters is this term, that is P2. Clear? It matters for us. Now guys, in this case, what will happen? We all know that corresponding to p orbital, if I am going to talk about the value of L, that is orbital quantum number, it will be equal to 1. Now I am going to start the explanation about the Breit's scheme. Okay, so focus on each and every point I will mention and I am talking about. For P2, okay, if I am going to write the value of L, we write the value of L just by observing the orbital. For p orbital, the value of L will be 1. For s orbital, the value of L will be 0. For p, it's 1. For d, it is 2. For f, it is 3. So that's how we take the values of L depending on the last valence electron where it is present. Okay, so that is present, let's say, in P2. Clear? So guys, in this case, the value of L is 1. Now corresponding to this, if I am going to talk about ML values, these are the orbital quantum numbers, but we call them the magnetic, okay, orbital quantum number. Now their values we will have from minus L to plus L, or you can write plus L to minus L. Don't get confused in both the sequence, because at different places you may get it differently. Somewhere it will be written minus L to plus L, somewhere it will be written plus L to minus L. But the difference of 1 should be there in all the values. Only the difference of 1. That means if I am talking about 1, so minus L to plus L, I will get minus 1, 0 and 1. Or I can write plus 1, 0 and minus 1. Okay, in any way. Is this clear till this point to everyone? Yes, Basit? No, Basit, that we will not consider. Just this is like the direct situation we are considering. Guys, let me know, is this clear till this point, how we are writing the values of ml? That's good. Let's talk about now the steps or the procedure we need to follow for the Breit scheme. You will draw or make a structure of this kind, as I am going to draw it now. Let's say this is representing ml1 and this is representing ml2. Okay, what is ml1 and what is ml2? So basically guys, ml is here, done. Now when I am talking about ml1, that is same, -1 0 1. When I am talking about ml2, that is also same, -1 0 1. Yes Sunita? Sunita, see, depending on P2, okay, let's say our valence electron is present in this orbital, that is P, and how many electrons are present there? 2 electrons. So that's why P2. Done. And the value of L corresponding to P, as I have mentioned here, that will be 1. So I have taken that value 1. Corresponding to the value of L, we can easily write the values of ml, which will be -L to plus L, or you can say plus L to minus L. In any way you can write it, that's okay. Okay, now -101 or 101 are the values of ml. Done. Next thing, guys, if we are going to talk about the Breit scheme, for that first of all we need to make this structure. Breit scheme we use generally for the two equivalent electrons. Right now we are using it, so generally we use it for the equivalent electron case. Now we will write ml1 here, ml2 here. So what are the values of ml? +1 0 -1, +1 0 -1. Same values I have written row wise as well as column wise. Done. Next thing, if I am going to talk about the values which I will write now in this structure, they will be, guys, focus, 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 so that each and everything will get clear to you. Done. Don't miss this part. Clear? Row wise, if you are adding this, you should add it in this. So like L you need to make, add this. So it will give you how much value? 2. +1 add 2. 0 + 1 will get +1. -1 + 1 will get 0. +1 0 will get +1. 1 0 0 will get 0. -1 0 will get -1. We are just adding column and row, column and row, column and corresponding row. Done. +1 -1, this is 0. 0 -1, this is -1. -1 -1, this is -2. Is this clear to everyone what I have done, how I have written all these values, and how I am getting like all the values I have filled within this structure? Is that okay and clear? Guys, before this session, I have already conducted one session in which I have talked about the spectroscopic term notations. So generally, like if you will watch that session, if you have missed it, please watch it once, because you will get to know about the basics of spectroscopic terms in this same channel, that is Unacademy Live CSIR UGC net. If you will check my previous class, that was about the spectroscopic terms. Okay, and there I have discussed the spectroscopic term symbol and how we find them, how we write them, everything. So if you will look at that, you will get everything clearly. Clear? So that symbol for the spectroscopic term is 2s + 1 Lj. Okay, the basic part of this I have already explained in the previous class. You can watch it once to know about the basics. Okay, now guys, in this case, let me know for these diagonal values, that is 0, 2 and -2, are the ml1 value and ml2 value corresponding. See, if you will focus on -2, focus on -2 right now. Column wise, we are having the value -1 here. Row wise, we are having the value -1 here. Are the ml1 and ml2 values same for the diagonal elements? Yes or no? Even for 0, if you will check vertically, horizontally, vertically, horizontally, you are getting same values. Is that okay? Clear? So guys, there is a rule, that is Pauli's exclusion principle. As per that principle, we can't fill any two, let's say, electrons having the same spin, we can't fill them in the same state. Okay, so to satisfy that condition, what we will do, if the states are same, like ml1 and ml2 are same here, then in that case spins should be different. That means ms1 and ms2 should be different. So let's say ms1 is plus half, so ms2 will be minus half, and the total spin will be equal to 0. So for all the diagonal elements, you will consider the spin 0. Okay, and what are those values which are diagonally present? We don't consider minus 2 separately. We'll take it like common. So that is, the values are L is equal to 0 and 2. Done? So minus 2 you will not consider separately. Like you will consider it just like this. Minus 2 to plus 2. So what we are having? Just 2. Okay, as I have told you that if L is equal to 1, we write it ml1 or ml is equal to minus L2 plus L. Similarly, if you are getting minus 2 and 2 both, so that means L is equal to 0 and 2. Corresponding to L is equal to 0 and 2, we will just take the spin 0 because spins cannot be same as the states are same. To satisfy the Pauli's exclusion principle, we all know. Devajani, I am repeating it. Shubhranshu, focus. Okay, I am repeating it once more. Shubhranshu and Devajani, let me know one thing. Is that clear that for the diagonal values, the ml1 and ml2 are same? Is that clear to everyone? Harinder, I will discuss the question, don't worry. But first of all, you will get the procedure. Let's say anytime if you are not able to memorize so many terms, spectroscopic terms, you will be able to find them if required. That's why it's important to know about this scheme and how it's gonna work. Done. Okay, Devajani, that's very good. Shubhranshu, is this also clear to you that for the diagonal values, ml1 and ml2 are same? If you will check vertically or if you will check horizontally, you will get the same values. That's good. Guys, now let me know, do you all know about this thing that as per the Pauli's exclusion principle, can we fill the electrons with same spin in the same state? Will the Pauli or do the Pauli exclusion principle satisfy this condition? Even if the electrons are having same spin, let's fill them in the same state. Can we do this? No, we can't. It is not allowed. In the same state, you can fill the two different spin. Okay, if you are filling two electrons in a spin, you will have the different spins for them. One up, another down. So plus half and minus half. Since for the diagonal elements, the values of ml1 and ml2 were same, hence the spins for those electrons will be different for the diagonal values. Since for the diagonal elements, the ml1 and ml2 values are same, which means the states are same, so spins of those electrons will be different. Spins are different means that if S1 is plus half, S2 will be minus half. Clear? Now, in that case, what will happen? The total spin will be 0. Clear? So that's why the total spin for the diagonal values, which are 2 and 0, the total spin for them is equal to 0. Is this clear to everyone now? Shubhranshu, Devajani and everyone. Thank you very much, Kirtika. And thank you very much everyone for joining the sessions. Yes, Sukhdev. Yes, Sukhdev, we'll consider the examples. Done? That's good. Now guys, what are the other values which we are getting here? So other values are 1. Except 0 and 2, what is the other value you can see in all these values? That is going to be 1. Okay, so for L is equal to 1, the value which you will have for spin, that will be 1. Total value of spin will be, or total spin will be 1. Because for L is equal to 1, the ml1 and ml2 values are not same, then in that case the spins can be same. Spin same means if one is plus half, another one can also be plus half, which means the total spin will be half plus half, which means 1. Is this clear to everyone? So as per Breit's scheme, we have got to know about this thing, that For L is equal to 0 and 2, spin is 0. For L is equal to 1, the spin is 1. You can even focus on one more thing, that is even values of L is having the spin 0. And odd value of L is having the spin 1, that is odd. Even in the different cases, this condition is going to get satisfied. Okay, even in the different cases, this condition is going to get satisfied and you can directly consider the values. So for even, take spin 0, for odd, take spin 1. At this point, you can work, okay, before the exam as well, so that you will get sure about it, but it works. In various cases, I have observed it and I am telling you after that only. Then now, guys, as per the spectroscopic term notation, 2s plus 1 Lj. Now, if you want to know about the values of J, what you will do? You have to make a table now. L, which is 0 and 2, and spin, that is 0 for 0 and 2. So value of J will be L minus S to L plus S. So what we'll get from here, it is gonna be 0, because both will give us 0, 0. So I'm just writing it once, and 2. Clear? Now, after this, what will happen? There was another value of L, which was 1. So for 1, spin was also 1. So it's gonna be L1, S1. So here we'll get 0, 1 and 2. Because L minus S will be 0 and L plus S will be 2. So we are getting 0, 1 and 2. Now if I'm talking about the spectroscopic term notations, that is going to be 2s plus 1 Lj. Spin, what is the spin here? 0. So for spin 0, the 2s plus 1 value will be just 1. For L is equal to 0, we know S, P, D, F, 0, 1, 2, 3. These are the values of L. So for L is equal to 0, we'll get S. So 1s, what is the value of J? J is 0. So 1s, 0. For L is equal to 2, what is the value of that spectroscopic term or capital L? It will be D. So it's going to be 1D. And what is the value of J corresponding to this? It is 2. Again, here, since S is 1, what will be the value of 2s plus 1, guys? That will be 2 into 1 plus 1, that is 3. So 3, and what is the value here? S is equal to, or L is equal to 1, which means it is P. 3P, 0, 1, 2. That's how you are getting to know about the spectroscopic terms by using the Breit's scheme. Okay, so now you know everything about the Breit's scheme, and this is how things are going to work. Is this clear to everyone? What we have done and how we have got like all these values and all these terms. And this is like all the information about the Breit's scheme. Now guys, I'm going to give you some of the questions based on this. Okay, so directly, like if we use the spectroscopic term notations corresponding to any equivalent electron case, we get like these kind of spectroscopic term by following the steps I have discussed with you. You can even have a look at all the steps, and once it is clear to you, be confident. You can do it easily. Done? Yes, Sukhdev. For D5, same. In the same way you will do, and there are going to be some different ways of solving the D5 case. Even the D3 case, because there are not total 2 electrons are present. So Sukhdev, in the plus courses I have talked about it. Like we have made the combinations A, B, C, D. I have written for all like plus half, minus half, plus half, minus half. You can check that session once as well, because that is going to be a lengthy process and it will take more time to discuss that completely. Okay, so right now as per the time we are having for this session, it may not be possible to complete it just in the remaining time. So check it once. I hope you will get it clearly. Yes, Kirti. हरिंदर, हाँ देखिए, आपने कहा 0 के लिए हमने 0, 1, 2 क्यों नहीं कंसीडर किया? हरिंदर, अच्छा यहाँ पर देखिएगा, अगर मैं बात करूँ J की, ठीक है, J की वैल्यू क्या होती है? L माइनस एस से L प्लस एस तक होती है ना. आप यहाँ पर L की वैल्यू कितनी है? 0, और S की वैल्यू भी कितनी है? 0. तो अगर आप इसको सॉल्व करें 0 माइनस 0, 2, 0 प्लस 0, व्हाट यू विल गेट? ज़ीरो ही तो मिलेगा यहाँ पर बस, तो हमने सिर्फ ज़ीरो लिखा, ठीक है। अगर हम बात करें L जब 2 है और S जब 0 है तो हमें क्या मिलेगा, 0 माइनस 2 दैट इज़ इन मॉड एंड 0 प्लस 2 दैट इज़ इन मॉड। क्या वैल्यूज़ मिल रही हैं, सिर्फ 2 2, सो दैट्स हाउ आई हैव रिटन जस्ट 2 हियर। बट अगर मैं बात करूँ L और S दोनों 1 1 है तो यहाँ पर क्या मिलेगा, 1 माइनस 1 2, 1 प्लस 1, तो क्या मिलेगा यहाँ पर 0 1 एंड 2, क्योंकि मुझे एक एक का डिफरेंस रखना है, जस्ट द डिफरेंस ऑफ 1 शुड बी देयर एंड विल गेट 0 1 एंड 2। इज दैट क्लियर हरिंदर? हाँ, yes Debajani, this is only for equivalent electron case. Kirti, your like comment or that message is not clear. For ml1 is equal to 1 and ml2 is equal to 0, can we consider S is equal to 0? हाँ, you want to say that if the ml values are different, then you can consider the spin. No, you will consider the same spins and that's going to be just 1. So odd values, total odd value which you get, as I have mentioned it here, for L is equal to 1, you will take S is equal to odd. So odd values of L generally going to have the spin 1, even values of L generally going to have the spin 0. Okay, directly memorize it and that's how you will be able to get the points easily. You don't even need to think about it ki, okay, I'm getting L is equal to 3, should I take 1 or 0? I will take 1 because that is odd. So for odd values the spin 1. Is that okay? For odd values generally spin will be 1. For even values the spin will be 0. And from where we are getting these odd and even values? From here only. Okay, is that clear? Done? Done. Okay, any other doubt anybody is having in this discussion? And guys, generally the questions which we get from this topic, they are going to be like, directly they will ask you to find the spectroscopic term notations. Right now I will give you one example related to this method so that it will get clear to you that what kind of questions you can expect in the exam. Clear? And sometimes they can be related to equivalent electrons case, sometimes they can be related to non-equivalent electron case. So for equivalent electron, if you want to find the spectroscopic term notations, we will use the Breit's scheme. As I have explained, I have mentioned each and every term regarding that. So now you know everything about it. Clear? And this is only information about the Breit's scheme you all should know. After this, even if you will have any doubt anywhere, you can let me know and we'll talk about all those points. Along with this information, guys, one more point is here, that is on every Wednesday, Thursday, Friday and Saturday at 7 p.m. I am going to conduct the session here on Unacademy live CSIR UGC net channel. Okay, so you all can attend these live sessions here at 7 o'clock for important topics, and this is a 75 days crash course going on. So some of the sessions have already been conducted and many are there which will be the upcoming sessions. Yes, Debajani, I am going to give you the question now. Mohammed Babar, see, don't get confused with that point. Clear? Is this clear as I have explained this to you? That how we are getting, like whatever values we are getting, positive and negative both here, that is the value of L corresponding to which we need to take the spin 0 if it is present diagonally. Okay, except 1, 2 and 0 were there and after that only 1 was remaining. And generally what happened, whenever we are getting the diagonal values, they will be the even values and corresponding to those even values spin will be 0, while corresponding to the odd values you will get the spin odd, that means 1. And this has been observed in general in many cases. Done. So that's how you can just consider it. Physics time, there is like a little different procedure. Okay, the things will remain same, the spin part, the values we are considering, they remain same, but the procedure get changed a little bit. Okay, and how we find it, if you want, we will discuss it soon in some of the sessions of atomic and molecular physics. No VS. I conduct the classes here on Wednesday, Thursday, Friday and Saturday. Okay, at 7 p.m. Now guys, let me just give you some example which you will be able to get, like, okay, this kind of questions you may expect in the exam. Just a second. There are so many questions which you can get in the previous years. One of them I'm going to give you just now. See? And I will also check your comments, so don't worry. Guys, one of the questions is, this one is from June 2016 CSIR NET exam. Clear? And one more trick you all should know, that is corresponding to any completely filled shell. Let's say it is S2, it is P6, it is D10. If like the valence electron is in the completely filled shell, then the spectroscopic term notation or the ground state spectroscopic term notation corresponding to that term will always be 1s0. Directly we can write, okay, for S2, D10, P6, okay, F14, which are like completely filled. So ground state spectroscopic term notation for them will be 1s0. Directly you can write it. Okay, it is a kind of trick you can consider. Now your question. And guys, you will try it in the homework, because exactly same procedure as I have explained you. For P2 you need to apply for D in this case. Clear? Have a look at this. And for ground state, how to find the ground state, I have done the discussion in the previous class of atomic and molecular physics here only. So you can check my previous session for that to know the Hund's rule. I have discussed the Hund's rule in the previous session. Which state in the standard spectroscopic notations is not possible? So they can ask you in any way, like they can ask you to find the spectroscopic term notations, or they can ask you which one is not possible. So once you will be able to know which are possible, you will be able to select from the options that which one will not be possible. Options are guys, you all will try it once exactly by following the same steps I have explained you. Clear? For d orbital, what will be the values? The value of L will be SPD2. Okay, so write ML1 and ML2. So it will be ML1, write it 2 1 0 minus 1 minus 2. Write 2 1 0 minus 1 minus 2, ML2. Okay, 2 plus 2 4. I am writing the diagonal terms. 1 plus 1 2. 0 plus 0 0, minus 1 minus 1 minus 2, minus 2 minus 2 minus 4. So for L is equal to 0, 2, 4, which are the even values, the value of spin will be 0. Okay, and corresponding to the values, remaining values will be, after 0 they will be 1, after 2 they will be 3, and maximum value was 4, which was possible. So spin will be 1 corresponding to that. Write them in such a way. 0 to 4, spin was 0 for all, okay, and for the 1 and 3, spin is 1. Find the value of J, that will be from L minus S to L plus S, and check corresponding to that. As I have written the spectroscopic term notation here, you just need to write as it is, okay, and you will check that which option is correct. So I am going to let you know that which one will be correct. That will be option A, and those who are getting it like option A, their answer is right. And guys, this is like one of the examples, and option A, that term you will not get in that spectroscopic term notation. Is that clear? Also guys, now tomorrow we will have our next class here at 7 o'clock, okay. Also 6 p.m. At 6 p.m. we are having our special class on Unacademy, okay. So from the Unacademy learning app, you can do the free registration for the special classes. There I am conducting the booster sessions right now. So if you want to attend those sessions, you can do the free registrations for them. And even in the link of this, the link of the special classes will be in the description box of this video. You can check. Also guys, there are so many new Unacademy Plus courses going to start on Unacademy Plus in the upcoming month. Clear? So in that case, if you want to attend the more regular live sessions by the top educators we are having on Unacademy Plus for your upcoming exam preparation, then you can take the Unacademy Plus subscription as well. And by using the referral code, that is AnjaliALive, as I have mentioned it here, and by applying it, you will get the 10% discount in the total Unacademy Plus subscription amount. Exactly in the same manner, you just need to write it. Clear? Or you can even use the referral code, that is AnjaliArora, because after you taking the Unacademy Plus subscription, you will get so many benefits like the weekly quizzes, doubt clearing sessions, mock test, PDF of important notes, guidance by the top educators, recordings of the live classes. If you have missed any of the classes, that will also be there. Clear? So guys, you can attend tomorrow's special class, that is at 6 o'clock, okay, and that is of nuclear physics. Today also we have discussed some of the very important points there. If you want to join those sessions, you can do the free registration for the special class from the Unacademy learning app, okay. You can check the link for the free registration or the special class on my profile by searching my name, AnjaliArora. Also, these are the benefits you will get after taking the Unacademy Plus subscription, and the best thing is you will get the guidance by the top educators. Also guys, right now I'm conducting the classes for electromagnetic theory, okay. Then after that we are having the sessions of atomic and molecular physics, we are having the sessions of quantum mechanics, we are having the sessions of electronics, practice sessions are going on, thermodynamics and statistical physics sessions are going on, which I am conducting right now. Along with that, other educators are also conducting many important sessions and courses. So once you will take the subscription, you will be able to attend the live sessions by all the educators, all the top educators, okay. Yes, Sukhdev, options are here. Clear? Thank you very much everyone for joining this session. Thank you. And tomorrow at 7 o'clock, this session here, and before that our special class of nuclear physics. Sukhdev, answer is option A. Done.